Okay, so the issue with this problem is entirely algebraic. The algebra is weird because of these negative terms. So there's actually three different approaches we could take algebraically to solve this. Actually, there's probably way more than three, technically speaking, but there's sort of three. There's a standard one that I would expect most students to try. There is one that is a little bit more annoying. And then there is a really clever trick that we can do. Could someone maybe help Melwin join the voice channel, or maybe they should tell him to log out and back in. They also might need to check their settings and change their output. I appreciate y'all's help. And you could tell them I'm recording this example, so they'll be able to view it later if for some reason they can't fix the audio issue right now. Okay, so here we are. Write an equation of this form. So I'm actually going to try to do this all three ways so that y'all can really just pick what feels most natural to you and what algebraic approach is most comfortable for you. But I'm going to do it the first way, the sort of clever way that makes it easier to do the calculations, but it also is harder to think of. So I'm going to do it that way first. So first method. So for the first method, I'm going to plug in my 2 points, so -1 and 3. I'm going to plug in my -2 and 23. And so when I plug in -1 and 3, what do I get? I get a to the -1st power plus b equals 3, right? My x value is -1, my y value is 3. And when I plug in here, I get a to the -2nd power plus b equals 23. All right, so if I think about my exponent rules, I can notice a clever approach to this, a way to sort of bypass some of the hassle. Because these negative exponents are very annoying to deal with, and we don't want to have to deal with them any more than necessary. So if we realize that a to the -2nd power is a to the -1st power squared, right, that just uses our exponent to a power property, then if we recognize that, we can solve for a to the -1st power here. So I solve for a to the -1st, and I get 3 minus b. And now I can take that and plug it into my other equation. So here, I could have rewritten this as a to the -1st power squared plus b equals 23. And I can plug 3 minus b in place of a to the -1st power. So I get 3 minus b squared plus b equals 23. Are y'all following me so far? All right. So this is the exponent rule, right? A to the, I'll write it in a different notation. Say x to the a all to the b power equals x to the a times b. That one. I'm just doing it backwards, right? -2 is -1 times 2. So x to the a to the -1 times 2 is a to the -1 to the 2nd power. Does that make sense? You're welcome. All right, so if I multiply all this out, what do I get? I get 9 minus 2, minus 6. So I'm going to skip that little bit of algebra here. So if I multiply this binomial out, I get 9 minus 6b plus b squared plus b equals 23. So 3 minus b all squared gives me 9 minus 6b plus b squared. And I've already got a plus b, and the whole thing is equal to 23. So this is a quadratic, and I would solve it just like any old quadratic. I'd set it equal to 0, and then I'd factor it or use the quadratic formula. So I've got one b squared term here, and then I've got -6b plus b, that's -5b. And then I've got 9, and when I subtract the 23, 9 minus 23 is going to give me a negative 14. Now when I factor this, what do I get? Hey, could someone tell Max to join the live session where I'm explaining it right now? Thank you all for your help. So if I take a look at this fraction, I don't have to use the quadratic formula here because I can factor this directly into b minus 7 times b plus 2 equals 0. So what does that give me for the solution? I set each factor equal to 0. I get b equals 7 or b equals negative 2. So since I have two solutions here, I'm going to call them b1 and b2. Now I don't actually have two solutions here, so I want to make that clear. So what's happening is that when I take this value for a to the negative first power, this value could have been negative or positive. But when I substitute it into this equation, I end up squaring it, which creates an additional possible solution, right? Instead of just either the one negative or the one positive one working, whichever one does work, when we plug it in here and we square it, it sort of generates almost out of thin air a second solution that has the opposite sign and might not work. So that's why we end up with two possible values for B. So what we're going to do is plug them into the possible values for A and see which one makes sense. So if I go back over here, a to the negative first power is 1 over a. And if I take the reciprocal, I get a equals 1 over 3 minus b. So now I can evaluate a1 and a2 based on each of these b values. So a1 is 1 over 3 minus 7, which is 1 over negative 4, or negative 1/4. Is that possible? Anybody? Because I took the reciprocal of both sides. So if I take the reciprocal of this side, I have to take the reciprocal of this side. So the reciprocal of this is 1 over 3 minus b. Does that not make it clear? All right, how about I do this step the long way? So if we instead did it this way, 1 over a equals 3 minus b, multiply a across, you get 1 equals 3 minus b times a, divide 3 minus b, you get 1 over 3 minus b equals a. Is that better for you? All right, no problem. Okay, so y'all, when we have an exponent with a base a, can we get a negative number here? Anybody? Hey, this is a pretty basic fundamental fact. It's the definition of an exponential function. Yes, thank you. It has to be positive. This is not possible. You cannot get a negative value for your base a. So that means my b1 was also not possible. So check a2. All right, well, I plug in my b2 into my formula for a. I get 1 over 3 minus negative 2. That's 1 over 3 plus 2. That's 1/5. Okay, that works. This works. So now my equation is f of x equals 1/5 to the x power minus 2. And then I think the question also says something about evaluate f of 2. Is that what it says? All right, evaluate f of 2. And so that means just plug it in. So I get 1/5 squared minus 2. That's 1 over 25 minus 2. That's mildly annoying because 2 is going to be 50 over 25. So that's 1 minus 50 over 25. And that gives me negative 49 over 25. Okay, so how do y'all feel about that? Does that make sense now? Yeah. All right, great. So before I do this the other ways, so what I'm going to do when I do it the other ways, I'm only going to do the middle steps here. So when I do the 2 other algebraic approaches, because it doesn't make much sense to kind of repeat the work that's the same. So for these other 2 approaches, I'll just do the little bit of algebraic work that is different, and then I'll kind of skip the rest. I do want to point out, make sure you all are spending time with definitions. If you don't learn the definitions of these functions, it really is going to cause you issues. Like if you don't know that part of the definition of the exponential function is that the base of this function has to be positive, that's going to cause you problems like this where you're not going to know which solution to take a look at. So make sure you review those definitions carefully in your notes. Spend a little time with them before you start on your homework problems. It'll make things go a little easier. But nonetheless, for these problems, the algebra is still tricky. So let's take another look at an approach to deal with the algebra. So let me just copy here. Okay. So another approach, and this is the approach that I would actually think is more likely for students to take, but it's at least initially take, but it's actually even harder algebraically. Is to solve for b, because you see, oh, I've got the a to the negative first power. That's hard to deal with. Instead, let me solve for b here and then plug it in. So I get 3 minus a to the negative first power. And then when you plug this into your second equation, what do you get? You'd get a squared, or a to the negative second, sorry, plus 3 minus a to the negative first power equals 23. All right. There's actually like so many ways to approach this that are really annoying, but they're just awful. So there's actually sub ways to do this one. So I hope this doesn't cause too much confusion, but I'm going to break this way down into 2 different things. I can take this, and this is still kind of clever. Requires sort of a careful thought. And I rewrite this as a to the negative second minus a to the negative first. And then when I subtract 23, I'll get minus 20 equals 0. So 3 minus 23 is minus 20. And if I rewrite this a little bit as a to the negative first squared minus parentheses a to the negative first minus 20 equals 0, what does this look like now? Like imagine this is just a single variable instead of to the negative first power. Looks like what kind of equation? I'll give you a hint. It starts with a Q. Somebody work with me. Quadratic. Thank you. I thrive on feedback, y'all. I gotta get some feedback. Yeah, it looks like a quadratic, right? Imagine if this was just x instead of a to the negative first. Well, you can treat it just like a quadratic. You can factor it like a to the negative first where instead of your x here, it's a to the negative first. And I need factors of negative 20 that add up to negative 1. That would be negative 5 and positive 4. Set the whole thing equal to 0. And now if I set each of these factors equal to 0 and solve them individually, like I would normally do for a quadratic, what do I get? I get a to the negative first power equals 5, and a to the negative first power equals negative 4. Remember, a to the negative first power is 1 over a. So if I want a, I just take the reciprocal. And since in this case I've solved for a first, I can immediately disqualify the negative a value. I don't have to plug that into the other equation. And here I can write b equals 3 minus 1/5 to the negative first power using my formula up here. Right there. And that gives me, well, 1/5 to the negative first power is just 5, so that's 3 minus 5, which is negative 2. So that gives me the same exact values that I expected to get, right? So that's one other approach. I don't actually need to break this down into another way because the third major way I'm going to deal with this algebra will cover essentially that version. So, all right, the last way I would deal with this is the following. Now, this I think is probably the most, for lack of a better word, the most sort of basic way to deal with it in algebra, but it's also, I think, kind of tedious. So it's not my favorite approach. So the first thing I do is solve for a. Oops. Let me start that over. I'll do that by first rewriting a to the negative first power is 1 over a plus b equals 3. And now I subtract b. I get 3 minus b is 1 over a. And just like before, when we take the reciprocal of both sides, I get a equals 1 over 3 minus b. Now, in order to plug this in, I need to rewrite this in terms of a. So the first thing I'm going to do is write this as 1 over a squared instead of a to the negative second power. And now when I plug this in, it becomes 1 over 3 minus b all squared plus b equals 23. Right, that's what I get for plugging this into the equation. Well, that's mildly annoying, but hey, it's 1 over 1 squared is 1 over 3 minus b squared plus b equals 23. If I divide by a fraction, I am multiplying by the reciprocal. So 1 divided by 1 over 3 minus b all squared is 3 minus b squared plus b. And that equals 23. And then I multiply this all out and I get b squared minus 6b plus 9 plus b equals 23. And then that gives me b squared minus 5b plus 9, or sorry, minus 14 when I subtract the 23. Equals 0. And then you just factor this and solve it the way we did the first method. So just continue doing, from that step, just continue doing what we did the first time. I think it's a little bit more tedious than the algebraic approach that we used here to just plug a to the negative first in directly. It adds a few intermediate steps just to get to the same exact thing. But that's it. That's all three algebraic methods I would recommend for dealing with solving those. I personally prefer the first method, but all three of them are valid and you should use whichever makes you most comfortable. All right, well, I'm going to stop that video recording.